root resolutions with spanning tree protocol. So the redundant topology can be overcome by using spanning tree protocol. So if there is two redundant links are there, so using spanning tree protocol, one redundant link can be blocked, so it can avoid the broadcast storms, MAC address database instability, multiple frame copies. That problems can be avoided. Spanning tree operations. In spanning tree operations, one root bridge per broadcast domain. That means if we switch A and switch B have two VLANs, VLAN 100 and VLAN 200. So in VLAN 100 it have only one root bridge. Then one root port per non-root bridge. If the switch is not root bridge, so it contains only one port is an root port, and one designated port per segment. Non-designated ports are unused. For example, switch X and switch Y. Switch X is an root bridge, so the both ports are designated ports. If the switch have root bridge, means that all connected ports are designated ports. Then the switch Y is non-root bridge, but switch Y can be connected to root bridge, so that port is an root port. So if an switch can be connected to root bridge, means that port is an root port, and this is a non-designated port, so this can be blocking. Spanning tree protocol root bridge selection. How the root bridge can be selection? For example, switch X and switch Y, two switches are there. So every 2 seconds bridge protocol data units can be sent parallelly. Switch X can every 2 seconds sends bridge protocol data units to switch Y, and switch Y vice versa send bridge protocol data units to switch X. In bridge protocol data units, it contains bridge ID. In bridge ID, it contains two field, bridge priority and MAC address. The bridge priority means the priority value. So the default priority value is 32768. So all Cisco Catalyst switch, the default priority value is 32768, and MAC address. If the MAC address is least one, that switch can be selected as root bridge. Here we can see, so the MAC address can be compared to least significant bits. We can see first of all 0 0. So each character have an hexadecimal 0 0 C 0 0. So here we can see 1 and it is an 2. So this is an least. Switch X is least 1, so switch X is root bridge, and switch Y is non-root bridge. So all other remaining switch can accept the switch X is root bridge. Spanning tree port states. There are 4 states are in spanning tree: blocking state, listening state, learning state, forwarding state. If the port in blocking state, means it can be it can be sent to listening state, learning state, then only it comes to the forwarding state. So blocking state, here we can see if the bridge protocol data units cannot be received, so maximum 20 seconds it can be waiting in blocking state. After that it can be going to listening state. After 15 seconds it go to the learning state. After 15 seconds it goes to the forwarding states. So these are the spanning tree have several different states. Spanning tree path cost. So depends upon the path also we can block that port. So if it is 10 gigabytes per second, means the cost of IEEE specification is 2. Previous it has 1, at present now have 2. 1 gigabytes per second means the cost of the path is 4, and here 1, previous 1. 100 megabytes per second is 19 and 10. 10 megabytes per second is 100 and 100. Spanning tree example, we can see switch X, switch Y and switch Z. First of all we can see the MAC address, because default priority value is 32768. It is common for all these switch. So we can see the MAC address 0C00, 0C, so both are same. Okay, next we can compare next octet 4141. Here also 41. Next one we can see 0, 1 and 2. So this one is an least, so 0. So here 1, 2. So this one is a least. So switch Z is an root bridge. So if the switch have root bridge, means it's connected. So the switch Z connected ports are designated ports, and the switch X can be connected to root bridge, so this port is an root port, and switch Y can be connected to root bridge, so these ports also root ports. Now we can check, this is a designator ports, the port 1 and port, the switch X port 1 and switch Y port 1. In this port, which one should be blocking? Now we can see the MAC address, switch X MAC address and switch Y MAC address. The switch X MAC address is least MAC address when compared to the switch Y, so this port is designated ports, so this port is a blocking port.